wonderful learning individuals. It is a pleasure. How are you all doing today? It is so great to have you. Thank you also so much for pressing the play button. I am Johnny, your host with HomeCountry Mathematics. Please feel free to stay to also learn because mathematics can really be fun. Now, let us learn some math together, shall we? All right, guys and gals, it is so great to have you. Thank you for stopping by, learning along with the channel. It is great to have you. So great to have you. Truly is. We're going to finish up and finalize this section. We are on Unit A, Section 1-2, the area or topic of adding and subtracting rational numbers. Let's go. So far we've been working on general basic integers, whole numbers, and then we eventually move forward towards doing decimals, which is always fun. Now we are on to fractions. Let's go. Do not worry. Don't let the word fractions scare you. Let's make it fun and easy because really it is easy. Let's do this. Our first problem, again, I don't like calling them problems. I like to call them fun challenges. Here we go. -1/6 subtracting 2/3. All right, let's go. So I'm going to make this easy, okay? We do have low value whole numbers, which is great. So we don't really have to go or look too far to find that common denominator. That's what we need to do. Looking at this, I know that 6 can be divided by 3, and also 3 can be divided by 3, right? We all know this. Whoops. Therefore, I have chosen to utilize or use 6 as my common denominator. Okay, let's bring some numerator values over. Don't forget your negative. It's easy to forget, so always think of your signs. Is it a positive or a negative value? Make sure you bring that over. We have same or similar common denominators, therefore our numerator is unchanged. Bring your subtraction sign over, and then we got to work this. What times 3 gives us 6? Well, that's 2. 2 times 2 is 4. There's our answer. Okay, so let's look at the number line or integer grid so that we can get a good understanding. Again, from 0, all values, all positive values go to the right from 0 positively and also infinitely. Whereas all negative values, they increase going in the left direction and infinitely. Okay, with that said, we can begin at, it doesn't really matter which number you begin with. I could begin with, again, you can look at these as 2 separate numbers. You really can. 2 separate numbers, 2 separate objects, however you want to look at it. We could begin at -4 or we could begin at -1. As long as you're going in the right direction, based on the sign, you will be good. All right, continuing on. -1, which is up here in the negative area. Awesome. Here we are, right? Gotta make sure you pay attention, as do I. Let's go. -1 and -4 jumps. Okay? -1, 2, 3, 4 jumps. That puts us at -5. If I begin at -4, well, obviously we're going -1 jump. Again, we're at -5. That is our answer. Okay. Again, when you have like signs, when the signs are the same for both, you can see this is a negative and this is a negative. You're technically speaking increasing, but it's in the left direction. Okay? All right. I'm going to leave that there. That kind of looks like a smiley face, and I like it. All right, -5 over and our common denominator is 6. Unchanged, right? So I know that is my final answer. Ignoring the sign, the next thing I would do is ask, can I reduce it? Is this reducible, right? And here's a quick way to help determine if a fraction is reducible or further reducible, okay? The way you do it is just, it's suggested, you don't have to, but it certainly would help, along with having your multiplication and or times table memorized, right? It'll benefit you in the long run. It'll help you, it'll assist and help you with grinding your mathematic problems quickly, effectively, efficiently, and with confidence. Okay, good luck with that. We all support you. And then back to here. Now, you don't have to memorize all the prime numbers. What are prime numbers, right? Let's get a quick definition. A prime number is a whole number greater than 1 that has only 2 factors, right? 2 factors. So what 2 numbers multiply together to give you that answer, right? So it only has 2 factors, 1 and itself. So if I factor 2, I can only get factor 2 and 1, right? 2 times 1. Same thing with 3. 3 times 1. It's all the same, right? So as an example, 7 is a prime number because it can only be divided by 1 and 7. While a number like 6 is not a prime because it can be divided by 1, 2, 3, and 6. You get the idea. Composite numbers are the other ones. Okay, they're typically, for the most part, well, they're the ones that fall in between. And for the most part, they are, not all, but for the most part, they are even numbers. Composite numbers, even numbers. Excluding 2, of course. So I'm going to stop at that, but if I look, I can see 5 is a prime number. Therefore, no more reducing. That's why I am showing you prime numbers, because it'll immediately tell you, hey, I don't have to reduce anymore. I'm done. Okay? Let's do another. 1/2. Subtract 4/5. Okay, again, we have 2 low values. They're less than 10 is what I mean, right? So, which is great. The point is, you don't want a really super large denominator for a value, because most likely you'll end up having to do a lot of reducing. You're just kind of creating yourself extra work. The simplest, quickest thing to do if you have denominators that are less than 10, as an example, just you can simply multiply them together. And that's how fast you can figure out your common denominator, just by doing that. Again, we know that 2 can't be divided. Well, we can, but we'll end up with a decimal, right? We want whole numbers only, right? So that does not work. So I'm going to go 2 times 5, which is 10. And then what times 2 gives me 10? That's 5. 5 times 1 is 5. Check my sign. My sign is a positive. Bring my subtraction sign. And 5 times 2 is 10. 4 times 2 is 8. Okay, on the side here, I could do the same thing. Okay, again, look at them like 2 separate whole numbers, right? We know this is a positive. We don't need to write positive because we know it's positive, right? So it doesn't matter if I go -8. Again, it's its own object. The sign must go with it. It's inferred positive 5, right? It's the same thing. I could draw boxes around each whole number or integer. And as you can see, all I've done is just switch sides. That's all I've done. Okay? Mathematically, integer-wise, I could still do the same basic addition, subtraction, whatever we're doing. As you can see, we have different signs. Therefore, technically speaking, we are subtracting, right? When you have different signs, you're subtracting, okay? So what I'm going to do is, as I always kind of explain, I look at the whole number and I go, 8 is bigger than 5. I'm just ignoring these for now, okay? 8 is greater than 5, right? So that means more jumps. 8 is going to have more jumps than 5 will, right? That's obvious. Therefore, with that logic, because 8 is the greater number, in the sense, the sign that's attached to it is going to be a negative. Therefore, I know my answer is going to be a negative. With that logic, I could simply just go 8 subtract 5, because I already know my sign. I could just do the subtraction, and there we go. So all I have to do is go 3. All right, let me show you the work. We could do this on the number line grid as well. I could start at 5. Let's do that. Remember, when you have a negative, you're going left, right? Just remember that. Right is positive, left is negative. Pick a number to begin with. I'm going to choose 5. I'm going left, 8 jumps. 1, 2, 3, 4, 5, 6, 7, 8. Puts us at -3. All right, so I'm going to separate this. I know there's small values, and that's fine. I'm explaining a couple of different ways or approaches to look at this. And whichever approach you like or prefer, by all means, utilize it and be consistent. All right, there we go. So I'm going to go like this. And looking at, just ignoring the sign, right? I'm going to go back here, and I can see that 3 is a prime number, which means No more reducing. So that's the final answer. We are done. All right, let's keep going. -7/8. Common measuring tape fraction. Subtracting a -3/16, which is also a common measuring tape fraction. -7/8, subtracting a -3/16. I'll go over it again. Imaginary 1. What's actually happening here is a multiplication. It's kind of a hidden step that most people don't know about, but that's what's happening here. We're going negative times a negative. So a -1 times a -3/16. Math rules, because it does rule. We have two negatives, right? So a negative times a negative will always equal a positive. It's the same concept I was teaching to you guys and gals earlier. If you have, let me just finish this up. We have even and odd, right? And it's always going to be the same. It doesn't matter if I have 40 negatives that I'm multiplying together, you're always going to end up with positive. It doesn't matter if I have 41 negatives, I'm going to end up with a negative. It's an even odd thing. Okay? It's an even odd thing. All right? So you can, again, this works great when you're multiplying. It's a little bit different with division, but if you do have a -1 being divided by a -1, it's the same outcome. You'll end up with a +1. Okay? A negative divided by a negative is also a positive. The other sense, you could end up having another negative on top. Right? It's being multiplied, so you're going to end up with a negative times a negative, which makes the top part a positive. And then the bottom part's going to be a -1, so that means if you're following along, hopefully, you'll still end up with a negative answer, right? Because you have an odd number negative, right? This is even, they cancel each other and become a positive. These two together become a positive. And then the denominator is a negative. One is a odd number, right? So, makes sense? I hope so. I know it's kind of a little bit messy, but I'm trying my best here. All right. So with that logic, we can rewrite this. -7/8. Plus, right? Negative times a negative is a positive. Again, it's an even number. 3/16. All right, so now we're down to two fractions, and it's pretty clear what we have to do. One of them is a negative. I could go on about the left-hand side plus the right-hand side. Same logic. Also, there are two independent items or objects, again as well, right? Okay. So, to keep my denominator low, I'm going to go with 16 because I know that 16 can be divided by 8. And obviously 8 can be divided by itself. Continuing on. 16's my denominator. Don't forget your sign, right? It's easy to kind of overlook and miss, guys and gals. Just remind yourself that you're working with negative and positive integers. Well, in this case, we're working with negative positive fractions, but if you have that mindset, you'll remember, oh, right, my sign, right? Constantly ask, what's my sign? Because if you miss a sign, well, you're definitely going to end up with an incorrect answer. Okay, doing the math here now. 8 times 2 is 16. 2 times 7 is 14. Bring in my plus sign. These are the same. No change in my numerator. All right, continuing the work. Negative 14 plus 3, right? Plus is going to the right. Negative 14 I will begin with. 3 jumps to the right. 1, 2, 3. That puts us at negative 11. Now that's nice when the values are low. As soon as you get over 26 in either direction, you're going to have to kind of do the long work, which is fine. I'll show you the steps on how to do that as well. Our denominator is 16. Again, I could look at the same logic. I could go negative 14 and plus 3. Excuse me. Ignoring the signs, I know 14 would have more jumps, right? Because 14 is greater than 3. Because 14 has the negative sign, that tells me that automatically, in my mind, I know my final answer when I add or subtract these two integers together, that my final answer is going to be a negative. Okay? It's another way of doing it. It's kind of like another check as well. All right, let me clean that up. And then let's do this again. Is 11 a prime number? Yes, it is. Therefore, we are done reducing. It's that easy, right? Isn't knowing prime numbers so great? Because you could quickly move on to the next question knowing, oh, 11 is a prime number. I could continue on. All right, let me keep going here. All right, negative 1 over 12. Subtract negative 3/4. All right, there we go. Same concepts. Imaginary 1. Negative times a negative is a positive. I could quickly rewrite this, which you have to do this step anyways. And 3/4. This is part of showing your work as well. Okay, common denominators again. I know we're close to 10. We're only 2 digits over 10, but I do know that 4 can be, or 12 can be divided by 4. Same thing with 4, obviously, being divided by itself. I'm going to keep my denominator low and choose to use 12 because they are nice denominators. They are, because they work nicely with each other, right? All right. 12. Okay, sign, bring your sign. Okay, remind yourself. 12 is the same. No change with this left-hand side numerator. Okay, left-hand side numerator, unchanged. Plus sign. 4 times 3 gives us 12. 3 times 3 is 9. Same thing, same math, same logic. I could start with 9 we're going one jump to the left, right? One jump to the left. It's all the same logic too, right? 9 is greater than 1 if we ignore the signs. The 9 has the positive, therefore my numerator is also going to be a positive. So we have 8 divided by 12, which, as we can all see, can be reduced because we know 4 or 8 can be divided by 4. Same thing with 12. That's going to be our factor, or greatest common factor, it's also called. I'll show the work. All we're really doing, guys and gals, is we're taking our numerator and denominator and breaking it into two numbers. That's really what we're doing. But we need that common number, right? 4 is the common one. The reason for that is so that we can cancel. Showing the work, what does 4 divided by 4 mean? Well, it means 1. Any number multiplied by 1 is just going to return to you the same answer, right? Okay, final answer. Positive 2/3. Right, good enough. Didn't give myself enough room there. All right, that's okay. Okay, let's do another. One more. Okay, there we go. All right. Last one, 2 1/4. They're giving us mixed fractions now, okay? That's okay. This is not a problem. I'll show you easily how this can be done. Okay? So what we need to do is, we have 2 1/4 subtract 6 1/3. What we need to do is turn these into improper fractions, okay? The fraction types that we've been working with so far. It's really easy to do. So I'll show the work here, 2 1/4. The steps are really easy. Denominator times the front number, or the whole number. So 4 times 2 is 8. 4 times 2 equals 8. And then you plus whatever the numerator is. Okay, that's going to give us 9/4. Okay. Let's do the other. It's the same steps, guys and gals, same steps. It's really that easy. Okay, 6 times 3 is 18 plus 1. 18 plus 1 is 19. Denominators are always unchanged, okay? All right, so now we have 9/4 subtract 19/3. Let me do this to create separation. All right, I'm going to continue to work here. I'm going to go with 4 times 3. Common denominator is going to be 12. 4 times 3 is 12. 9 times 3 is 27. What's our sign? It's a positive. Bring this over. Negative. 4 times 3 is 12. 19 times 4. Going to end up with kind of a big number here. 9 times 4, so 9 times 2 is 18. Double that is 36. Carry the 3. 4 plus 3 is 7. Okay. So seeing the work here, looking at our numerator, I'm just going to bring the work down to here. Okay. I'm just going to do that. All right, so looking at these, our numerator values, we have 27 and we have negative 20, sorry, silly me. Negative 76. We know that the 27 is a positive, right? Ignoring the signs for now, we know that 76 would have way more jumps than 27 would, right? Looking, okay, so now we look at 76 and we go, oh, okay, 76 has the negative sign. Therefore, our answer is going to be a negative. Okay? We have different signs, which means we just simply need to subtract the two values. I already figured out my sign, so I don't have to worry about it now. All I need to do is subtract the two values to get my answer. I'm going to borrow. This is 16. 9, 10, 11, 12, 13, 14, 15, 16. So that's 9. And 6. 6 take away 2 is 4. Right. So 49. Subtract, or negative 49 over 12 is what I get. Can we reduce? They do look like reducible values. If we, let's see, quickly. My list isn't that big, so what I mean is this. My prime number list, 49's not on there. 12 is obviously not a prime because we know it can be reduced and broken into 6 times 2 and 4 times 3, right? Right? Those are the two options we have. And 49 is the result of 7 times 7. Well, we know 7 doesn't... Well, we can divide it, but we'll end up with a decimal value. We don't want a decimal value. Fractions are whole numbers, right? Whole number numerator, whole number denominator. Okay? So that's no good. Whoops. So quickly, let's see if I can find the prime numbers list. 49, right? We already figured it out, right? We know it's not a prime number. Again, with what I just said, 7 times 7 gives us 49. So just that logic alone tells us that, well, two things. It tells us that we can still reduce, but again, we need that common number. There is no common number between the two, between the numerator and the denominator. There's no common number. Whoosh! So, thinking this, I'm thinking we're done. Okay, I can't see us reducing that any further. All right, I can turn it into a mixed fraction, and that's easy. So what we need to do is get as close to 49 without going over. So we have to create multiples of 12. 12 times 2, double the numbers, that's 24, right? Well, let's double the numbers again. That's 12 times 4, which gives us 48. Oh, perfect. That's what we want. 48, because it's still less than 49, right? We don't want to go over, right? So our front whole number is going to be 4. 12 times 4 equals 48. All I'm doing right now, guys and gals, is turning our answer from an improper to a mixed fraction. Okay, 4 is going to be our front number. That's it right there. We have 48, so to figure out my numerator, all I need to do is go 49 minus 48. Oh, it would be so nice to have a pen tablet. Okay, which obviously gives us 1, right? Oh, don't forget your sign as well. Let me clean this up. You get the idea. Okay, don't forget the sign. I'm going to put a negative in front here. Again, our denominator is unchanged. And there we go. All right, that is it. That is it, guys and gals. I appreciate you watching and learning along with the channel. I can't say it enough. It means a lot. I appreciate whoever you are, wherever you are, watching the content and learning along with the channel. That is super awesome. I'm going to leave it at that. I'm Johnny. I'll see you in the next video. And actually, we're going into the next unit now, Unit A. And we're going to be working with more fractions, but we're going to be multiplying and dividing fractions. Don't worry, it actually is getting easier. Stay tuned, and I'll see you in the next video. Take care for now.